Hey guys, welcome to Deep Dive Coding. Today we solve LeetCode problem of the day, and that is find resultant array after removing the anagrams. So I will show the two approaches. That will be the brute force one, another is the optimal one. Then optimal one I will show how to use the multi-set hashing concept using the prime numbers. This is an interesting concept of it. So I will show that also. First let me discuss the brute force approach. So the problem is basically says if we find the any anagrams, let's say we have the words array is given this the like string of vector that will be like in the initially this words is given this, and if we want to perform let's say we pick index I that is under the range of this array, and we go into the last element that is I minus 1, and these two elements anagrams is the same, then we have to remove the I element. So basically the if we start from the 0, we will not start from the 0 because 0 minus 1 that is minus 1 index is not valid one, so we initially start from the index 1, so that is ba, and I minus 1th index is b 0 index, that will the string will be the ab and ab. So what means the anagram is, if you let's say string a equal to you can this is the string a, and string b, let's say this is be the string b. So if this frequency of the all elements is same, so string a frequency would be 2 and b is occurrence is 2. Also for the string b, a occurrences is 2 and b occurrence would be also 2. So these two are the anagrams of each other. But if it is this way that let's say reduce the one a frequency, and then now a frequency of string b will be the 1, so these two elements are not, these two string are not the anagrams. So string anagrams means the frequency of each character would be the same. So if you look into this thing like AB and BA, these two are the anagrams because A occurrences is 2 and B occurrences is also 2. So we have to remove one elements from it, and that will be the BA, because as the problem is given that we have to remove the ith words if I and I minus 1 words is anagram. And in the next step we have this array, we removed BA, and again we check whether it is whether BBAA is anagrams with ABBA. So these two also the anagrams, so we also remove the BABA string. After that we found the CD, and CD is not anagrams with ABBA, so we move ahead of it, and again we check CD and CD, these two are also anagrams, so we remove this one. So I think you are able to understand this problem. So we basically we have to check whether it is anagrams with the last string, and if it is anagram we did not consider that in the array. So I will quickly write the brute force approach first. So first of all let's take a vector of string that will stores the answer, and after that we iterate through the words array. So let's say this is string and words. After this thing you can pass it is as the reference so that we do not have to copy each and every time. So we have to check if empty or not an anagram of previous word and previous word, then add to the result. That means what we have to do, if vs.empty, that means current now we are processing the first element, or we did not first element, that in that case vs that will be the vector of string, that will be we are storing the answer. So what we store over here, I will write it. So to store answer. Okay, so vs.empty will be the first one that we processing the first element of words, and otherwise if each anagrams, here we pass two things like string, one is string and other one is vs dot back element, last element of whatever we push in this vector. And if it is not an anagram, then we have to push this element in the vector. That means string, we push that element, because over here we see that when these two are not anagrams, so we effectively this cd will be pushed into the array and processed further, like further for the CD, like compare for the CD. So now after these things done, we simply return the VS as a vector. So after these things done, we have to define the uh, function that is anagram. That will simply compare to string frequency is same or not. Let's say string A and string B. And what we can do that, first of all, A dot size not equal to B dot size. That means if the size is not equal, then it is not possible to be the anagrams. And after that, what we can do, we sort the array. Let's A dot begin and A dot end. We sort the not array, we sort the both string, and we sort A string and B string, that is B dot begin and B dot end. After these things sorted, we iterate over the array. That means for int I equal to 0, I less than A dot size and I plus plus. Over here it is A and B size is equal. Why it is equal? If it is not equal, then in these steps it will return the answer. So if this amount of code is executing, that means A size and B size is equal, so we are taking just one of their size. Let's say it is A size. So if the A of I not equal to B of I, that means in that index this character is not equal, that means it is not possible to possible is anagram, because we already sorted. So each character should match with each positions A and B also, and at last all our matches, then we should return true because it is anagram. Now I think it's correct. Now let's try to run this code for the sample test case. Okay, I will discuss the time complexity of it also. So yeah, it's accepted for the sample test case, and now let's try to submit this thing. This is also accepted, although yeah, it is also accepted. Also the bits is 100%. Now I will show the also better approach, but before going into that thing, let's try to discuss the time complexity of it. So it will run for big of words dot size, because each element will run, and after that it will checking the each anagram. So and you can say each anagram function will take, over here it will take, let's say A size log of A size. For sorting, that is n log n, it will be the B size log of B size, and at last over here it will run, let's say A big of A size. So you can say that this will take big of in, that is words dot length, let's say words of I dot length log of words of I dot length. This much amount time it will take to run, and for each steps we are calculating these two things, this we are calling this. So effectively the time complexity would be that will be the big of words dot size and into big of words of I dot length into log of words of I dot length. That will be the total time complexity of it. So I will show the better approach, where we just not to compare these things, we can compare effectively. Over here we are just brute forcing the things, that we are sorting the two string and just normally checking that whether it is correct or not. And in this case we are repetitively checking the same string for again and again. Let's say if you have this case, I will show you that. Let's say this one. So A B B A, this will each time this will sort the 3 times, like not 3, yeah, it will sort the 3 times, because we are checking first A B these two, then these two, and then these two. So again and again we sorting the same string, so it will increase the time complexity. I will show you where it is not able to, where it is reduce this checking function. Let's jump into that thing. Okay, I will just comment it out. Okay, now let's try to optimal approach. The optimal approach will be the using the multiset hashing using the prime numbers. So what we do, we have to calculate the prime numbers of each string, not prime number, we have to calculate the hash value of the each string, and that will we effectively compare that whether it is same hash value with other string or not. If hash value is equal, then we simply conclude that the string will be also the equal. So over here we can define the steps. This is the multi-set hashing value. So over here it is order does not matter, but the frequency matters. So as the question is anagram, so over here it is frequencies matter. And now let's try to discuss the prime based multi-set hashing. And first step we have to do the take each index with the prime numbers. That means we have to take the, if we have 26, so prime of 26 will have the 26 over here, 26 prime numbers, and each with each index like 0 to 25 have the two prime numbers. Let's say it will be simple mapping of first prime, A with first prime, B with second prime, and so on, and Z will be the 26th prime. Now what we have to do, that calculate the multiset hash value. For each number we multiply the corresponding index prime number and take a unique to make a unique number. What we want to say over here is, let's say you have multiset m1 that have 0 2 times, not yeah, okay, so 0 2 times and 2 3 is 3, and let's say this one. So hash value would be simple. Let's say you define the primes of 4. You can say that this will be first 4 prime numbers. You can say 2 3 5 and 7. Okay, so what we want to do over here is hash value would be this way, that we are first is 0, so we take the 0th prime number, 2 into, again you have the 0, so we again we multiply with again 2, and it is 2, that is 0 1 2, that will be the 5, multiply with 5, and again is 3, and that will be the 7 into 7. So as over here we are just taking this value, and at that index we multiply that prime numbers, so this will be the hash value. And according to arithmetic prime factorization, if the prime factorization is different, then it is different number, and else it is same number, because the prime factorization is still simply like that way. Okay, so now let's try to define the code so that you can effectively understand with what I want to say. And first of all we have to define the prime numbers. So let's take a prime numbers of 26 prime numbers, because A to Z that have 26 character. So the prime numbers of 26 can be const int primes. Okay, 26 array, that will be 2 3 5 7 11 13 17 19 again 23 29 and 31 37 again 41 43 47 53, okay, 53 59 61 67 71 again 73 79 83 89 97 and 101 finally. Okay, so okay, we have the 26 prime numbers. And another thing, we take a mod of it as we are dealing with the multiplication. So first of all we define the define ll as long, so we take const long of mod, that you can say 9 plus 7 29 plus 7. Now define the hash of the string. We have to calculate the string hash. So over here we take a string, const string, let's say w, and we have to calculate the hash value of it. So hash, initial hash value would be the 1, because we are taking the product, so it will be the 1. And now go through the each character of it in the w, and hash value would be the hash of hash into, we are just simply multiply with the corresponding prime numbers. So index will be the ch minus a, that means which that means the a have the 0 index, b would be the 1, and c 2, and so on. And after that we take the mod so that it will not overflow, and at last we have to return the hash. Okay, we define the hash value, and now we effectively calculate that whether it is we effectively check that anagrams. So again we take the vector of string to store the answer, that will be the vs. And one thing we have to take that vs last element has value, that will be initially, let's say, -1, so that it will not equate with any others. And string str of words. Now iterate through this thing. Now we have to calculate the str hash value, current string hash value, that will be the hash string of str. We calculate this str hash value. After these things done, so again we apply the same concept, like either vs.empty, or if it is not anagram, so again we say that vs.empty. If it is vs.empty, then we are processing the first element, or string hash value not equal to vs last element hash value. That means we have to push this thing in the vector answer array, vs.push of pushback of str, and we have to again update as it is the last element of the vs. So just copy over here, and this equal to a string hash value. And at last we have just returned the answer. Now let's try to run this code. I will discuss the collisions of it, like, yeah, it's run for the sample test case. Now let's try to submit this code, and I will also discuss the time complexity of it, and also the collision. Yeah, it's accepted. Now let's try to discuss the time complexity, what we improved. So over here it does not improve, so we iterate the words, each words, each thing in words. And after that we are just checking this thing, like we are calculating the hash string function. So this function is called for the each string at once. So this will take the words of I dot length, and that means you can say that this will take big of words of I dot length, and this will again go through the words of dot size. So effectively it will improve the time complexity. So the total time complexity would be time complexity would be words dot size into words of I dot length. But here it is possible to, as we are using the hash of it, so it's maybe possible that it will collide with another, like two string collide means that two string is different, but hash value calculation of hash value is such a way that this hash value is same, and we conclude that these two string are same. That will be collide means. So but it is not collide in this case, because why, I will show you. Because over here the theoretical of the collision, like using the unique prime for each characters, the fundamental theorem of the arithmetic guarantees of unique prime factorizations. That means if the prime factorizations of the two different like prime factorizations of two numbers is different, always different, So as we are using the prime numbers, so we are multiply with we are taking the multiply and getting the numbers, so it will be the different, so it will not collide with each other. And for the different multiset, letters cannot produce the same hash, perfect for the anagram detection. And but the practically we are saying that we are using the mode of 1e9 plus 7, so it might collide if we increase, if we exceed the multiplications above 1e9 plus 7, so that can collide. But the probability is for the, but the typically the input sizes is too low, so the collisions are negligible. I think this is clear. Thank you for watching. Stay tuned for the more videos.